Okay, here we are, guys. We are now on quarter one, week 4, day 3. All right, what it's saying to do is find an equivalent fraction. So once again, we did this a little bit ago, I think 2 days ago. To find an equivalent fraction, it's pretty simple. All you have to do is treat the numerator and the denominator the same way by either multiplying or dividing them both by the same number. So if we do 1 times 2, that gives us 2. And if we do 2 times 2, that gives us 4. So 2 over 4 is an equivalent fraction. Or we can do 1 times 3 and give us 3, and 2 times 3, which would give us 6. That would also be an equivalent fraction. All right, so let's go over to 1/3. We have 1 over 3. We can do 1 times 2 and get 2. 3 times 2 and get 6. 2/6 is the same as 1/3. And what I mean by that is if you had like a pie and you cut it into 3 equal pieces and you ate one of them, that would be the exact same thing as taking that same pie, cutting it into 6 pieces, and eating 2 of them. All right, so on and on. So 1 times 3 would be 3. 3 times 3 is 9. So there we go, equivalent fractions. And we can go on forever. 1 times a million would be 1 million. 3 times a million would be 3 million. That would be an equivalent fraction. Find the product. All right. So 5 times 2 is 10. Carry that. 7 times 5 is 35, plus 1 more is 36. 5 times 3 is 15, plus 3 more, 18. 5 times 6 is 30, plus 1 more is 31. All right, and then we have to put the little space provider there, or the space taker upper. All right, so then we have 7 times 2 is 14. 7 times 7 is 49, plus 1 more, which is 50. 7 times 3 is 21, plus 5 more is 26. 7 times 6 is 42, plus 2 more is 44. And then we're going to have to add these up. 0 and nothing is 0. 6 plus 4 is 10. We're going to carry the 1. 8 plus 1 is 9. 6 plus 1 is 7. 3 plus 4 is 7. And 4 plus nothing is 4. Coming over 3 places, put the comma. So we should have 477,900. A strip of paper is 9/10 of an inch long. You need to cut, so we have 9/10 of an inch. You need to cut the paper into 3/12 inch pieces. How many pieces will you be able to cut? All right, so we know that 9/10 is the amount that we have. And we're going to have to divide into it the 3/12. Well, here we go. Let's go ahead and solve this. We have 9/10 times 12 over 3. Hey guys, do you remember the cross-reducing things we talked about? This is really going to be helpful in this one. Because look across on this one. We have a 12 and a 10. And we know that a 2 goes into both of those. So 2 goes into 10 5 times. 2 goes into 12 6 times. So that's already saved us some simplifying later. But then look across this direction at an angle. We know that 3 goes into 3 and 9. 3 goes into 3 one time. 3 goes into 9 3 times. So now we've made our lives just a lot more simple. So instead of working with these really big numbers, we're just going to do 3 times 6. 3 times 6 is 18. And 5 times 1 is 5. So instead of simplifying, we already have it taken care of. So at this point, we just see that this is an improper fraction. So anytime there's an improper fraction, we want to make it into a mixed number. So 5 goes into 18, 5, 10, 15. 3 times. We've used 15 of the 18. So there's going to be 3 left over out of the 5. So 3 3/5. How many pieces will you be able to cut? 3 3/5 pieces. Okay, guys, so we're going to find the quotient. All right, so how many times does 17 go into 6? Well, it doesn't. But does 17 go into 66? Yeah, it'll go into it 3 times. 7 times 3 is 21. 3 times 1 is 3, plus 2 more is 5. 66 minus 51 is going to be 15. Okay, so then we're going to bring down the 2. All right, so how many times? So this is probably going to be a pretty big number because 17 goes into 152. I'm going to guess about 8. Let's try 8 to see if that works. 7 times 8 is 56. 8 times 1 is 8, plus 5 more. 15. All right, so then we're going to go ahead and borrow here. We got 12 minus 6 is 6. 4 minus 3 is 1. All right, so that's under 17, so that's correct. That's the correct one to do. And then we have a 163. Well, I would have to say we're going to have to go with a full 9 on that one. So 9 times 7 is 63. 9 times 1 is 9. Plus 6 is 15. All right, so it's going to be 0, 1, so it's going to be 10. And then we're going to have to put a 0 and bring it down. All right, so how many times does 17 go into 100? Let's see. How about 5? Let's try 5 on that one. 7 times 5 is 35, so we have the 3, bring down the 5. 5 times 1 is 5, plus 3 is 8. So we're going to subtract that. So we're going to have to borrow. This becomes a 9. Okay, so 10 minus 5 is 5. 9 minus 8 is 1. So, all right, so that's 15 again. So then we're going to bring down a 0. So we have 150 that we're going to divide into. Well, earlier on we used 8. And we got 100 and, yeah. So we used, well, let's see. Let's try the 8 there. 56. So yeah, that actually ended up being 136, right? 136. All right, borrowing again, make that a 4. Make this a 10. 10 minus 6 is 4, so 14. Bring down the 0, so 140. So, of course, we're going to probably have to do another 8 because that was 136. So we could probably stop right there. So we have 389.58 8. Okay, or we could do 389.59. Okay, would be a good answer for that quotient. Okay, we have to find the sum of two numbers that have decimals. And so what do we have to do with the decimals? Yep, we have to line them up. So we have 58.887 and we have 92.234. Let's add them up. 7 plus 4 is 11. 8 plus 3 plus 1 more is 12. 8 plus 2, 10, plus 1 more is 11. 8 plus 2 is 10 again, plus 1 more is 11. And then we have 5 plus 9, which is 14, plus 1 more, which is 15. At that point, we bring down the decimal, and our answer is 151.121, or 151 and 121 thousandths. All right, now we're going to find the difference. Once again, we have decimals, so what we have to do with those? We have to line them up. So we have 85.777. And then we have to subtract that from 42.432. 7 minus 2 is 5. 7 minus 3 is 4. 7 minus 4 is 3. 5 minus 2 is 3. 8 minus 4 is 4. The answer is 43.345. What is the least common multiple of 3 and 4? So let's count by threes. 3, 6, 9, 12, 15, 18. All right, so let's count by fours and see if we can kind of match up with the number up there in the threes. We got 4. Is 4 up there anywhere? Nope. 4 times 2 is 8. 8's not up there. 4 times 3 is 12. There we go. The least common multiple of 3 and 4 is 12. What is the greatest common factor of 28 and 72? All right, so again, greatest common factor, which means it's going to be a number that you can divide into 28 and 72. So it's going to have to be less than 28 because it has to be able to divide into it, right? So let's find all the factors of 28 real quick. Let's see, 1 times 28 for sure. We know that. 2, yeah, it's an even number. 2 times 14. 3, I know doesn't go into it because 8 plus 2 is 10. 3 doesn't go into 10. 4 doesn't go into it. Actually, yeah, 4 does go into it. I know it does. 4 goes into 28. Yeah, 7. 7 times 4 is 28. How about 5? Nope. 6? No. And 7? Yeah, it does. But now we're repeating, so we can just stop right there. All right, let's look at 72. I think this one has lots. 1 times 72, of course. I'm going to write a little smaller so I can fit it. 2 does because it's an even number. And let's see, you would have to double 36 to get to 72. 3 does because 7 plus 2 is 9, and 3 goes into 9, so 3 has to go into 72. And that goes in 24 times, I would say. 4 goes into 72 18 times. 6 goes into 72. 6 times 12. And 7 doesn't. 8 does. 8 goes into 72. It's 8 times 9. Well, then 9 goes into it, so now we're repeating. So at this point, we can just see what is the largest number that's both in this group over here and that group over there. So we have a 1 on both sides. We have a 2 on both sides. Let's see, there is a 4 on both sides. Is there a 7 or a 14 or a 28? Nope. So the largest number that's on both sides is the number 4. So the greatest common factor of 28 and 72 is 4. Okay, it says write the ratio of apples to oranges in simplest form. So we are literally comparing apples to oranges right now. And how many apples are there? Well, there's 1, 2, 3, 4, 5, and 6. So, and there's 2 oranges. So it says ratio of apples to oranges. So they're starting with apples and ending with oranges. So you have to do it in that same one. If they said oranges to apples, you would have to have the number of oranges first and the number of apples second. So apples to oranges would be 4, and then a colon, 2. That's one way to do it. Another way you could do it, if you guys remember, is 4, the word 2, 2. And the last one is 4 over 2. So we have 4 colon 2, 4, 2, 2, and 4 over 2. All right, there's the ratio of apples to oranges.